All right, in this video, I'm going to go over radicals, not political radicals. It's a little too much for me to handle. Not free radicals, although this lesson on mathematical radicals is free. So, radical 25, that's what it is. Now, some of you might say square root, but there's a reason why we don't call them square roots anymore. Radical 25. This is the radical symbol. You might recognize it. It's like division, but with a little check mark at the end. Looks fancy. This number underneath the radical is called the radicand. I don't know why it's important for you to know that, but it is. So just keep that in mind. Now, when we're taking the radical of something, we're looking for a number that multiplies by itself to get that radicand. Say it again. We're looking for a number that multiplies by itself to get that radicand. So if you don't know what radical 25 is, you can always factor it. Now, what is a number that we can multiply to get 25? There's only one I can think of, 5 and 5. 5 times 5, 25. 5 is the same number, right? There's two 5s there, so the answer is 5. Now, positive 5 is the principal root of 25, but technically negative 5 could also be multiplied by itself to get 25. So really, there's two answers to every radical, most radicals. Well, half of them actually. But usually when we're just simplifying these expressions, that's what this is a radical expression. We just go with the principal root, which is the positive 5. But it's important to understand that a negative times a negative is a positive, and so roots can also be negative. So let's go over a root that maybe doesn't work out so nicely, like 18. What's radical 18? Well, it's not a perfect square. So how do we figure it out, though? We still have to simplify it, though. And to figure out if there's a perfect root somewhere in the factors of 18, the radicand, we need to factor the radicand. So 18 factored into, well, it's an even number, right? So we can divide it by 2. 18 divided by 2 is 2 times 9. Oh, look, there's a perfect square. What do you multiply by itself to get 9? 3, right? So we have a root in there with 2 left over. So we could write that as radical 9 times 2, and we can take them individually. Radical 9 times radical 2. If writing it like that helps you, then go ahead and write it like that. Radical 9 is 3 times radical 2. And that's your answer. That is as simplified as we can get it, because radical 2 is an irrational number. Only an irrational number multiplied by itself gives you radical 2. And we don't like to write out that whole decimal every time. So we just leave it as radical 2, which is a more exact answer, because if you wrote out the decimal, you'd have to write it out, round it up or down somewhere. So they call this an exact answer. So when you have a homework problem where they ask you to leave your answer in exact form, that's what they're talking about. All right. Now, there was something like this in the book. Well, let me use a different number. They took a radical of something twice. Well, a radical you can think of as kind of like parentheses. You can just ignore the outer parentheses and just focus on the inner parentheses first, right? So what's a radical 36? 6, right? But we still have another radical left over. So we put that over there. 6 is not a perfect root. It doesn't have any perfect roots inside of it, so that's your answer. Because that's just 2 times 3, right? Those aren't perfect roots either, so can't be simplified any further than that. Positive negative radical 6 is the answer. But we're just going with the principal root for now. Now, somebody somewhere along the line realized that they don't want to write out radical, for every time they want to do this. So they figured another way to write it is like this, with a little 4 above the check mark there. That is the same thing as this. Okay. This is called the 4th root, if you wanted to go with square roots. Yeah, that is how that works. And some things do have perfect 4th roots, like 16. That is 2 multiplied by itself 4 times. 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4, 16. So that's what that is. Now, do not get this confused with this. This is a completely different number. This is 4 times radical 16. What is radical 16? 4. 4 times 4 is 16. See, completely different numbers. This is 16. This is 2. So be careful when reading your math problems. If that number is above the check mark and it's smaller, usually a little smaller, then it's part of the root there. Now, there's another way to write that. 4th root of 16. And this is kind of the concept behind radicals. It's actually just an exponent. It's an exponent that is a fraction. 16 raised to the 1/4 power. Same thing. Now, there's a concept we need to learn here. We cannot add radicals together if their radicands are different. You just can't do it. Plus, it's also part of the rules of the order of operations. Addition and subtraction is last. And I just told you, radicals are exponents, right? They're actually almost as prioritized as parentheses are. So might as well just assume those are parentheses like I brought up earlier. So you got to do the radicals first individually. So radical 25 is 5. Radical 144 is 12. You need to know your multiplication tables up to 12. Maybe 13. I didn't bother with 14 or 15. But 12 times 12 is 144. So then you add them together and you get 17. Now, there's a difference. What if we add inside the radical? Now, we can add them together because they're in the parentheses there, in those understood parentheses. Know the difference. There's 169, right? 144 plus 25, 9, 6, 1. Yeah, 169. Square root of 169 is 13. Completely different answers to very similar looking problems. So you gotta understand that these are separated and these are not. They're included. All right, now that's addition and you can probably use subtraction now too. So we're gonna skip subtraction. Now let's go straight to multiplication and division all at once. Square root of 2x squared over 9x to the, no, not x, 9y to the 4th. Okay. Now, because none of these are being added or subtracted, we can take the root of each individual number. Okay, remember that. You can only do that if it's multiplication and division. So, radical 2, nothing we can do about that. Radical x squared, it's a number that multiplies by itself to get x squared, x times x. That's easy. It's basically saying x squared raised to the power of 1/2. And if you remember the exponent rules, when you take an exponent of an exponent, you multiply them together. So 2 times 1/2 is actually 2 divided by 2, which is just 1, and x to the 1 is just x. So that's x radical 2. That's just the numerator. Radical 9, 3, radical y to the 4th. Y to the 4th. You want to do this again? 4 times 1/2. That wasn't so bad. And yes, that is the final answer. That is as simplified as it gets. All right, let's do another one real quick. Kind of a curveball. But this is also addition again. 6 radical 20. Radical 5 plus 6 radical 20. Okay. Now the 6 is not small and above the check mark, so it's just 6 times radical 20. Whew, don't want to deal with a 6 root. Eesh. Can we add these together? No, we cannot, because the radicands are different. So this is as simplified as it's going to get. So let's check out this one. We need to factor that radicand at 20. What multiplies to get 20? Well, there's 2 times 10. What else is there? There's 2 times 5. 5, we can't factor that anymore. And 2, we can't factor that anymore. But something multiplied by itself in there. So that's interesting. So we can take a 2 out, right? Because that multiplied by itself to get 4. So there's a 4 times 5 in there. That's a perfect square. That's not. Square root of 4 is 2. So when we move that 2 out, it's multiplication, right? Let me write it down like this first. This is a concept that a lot of people might fail to get. Square root of 4 multiplied by 6 multiplied by square root of 5. Doesn't matter the order because it's multiplication, right? But when we have those radicals together, we multiply them together to get 20, right? So when we separate them and this one becomes 2, it's being multiplied by that 6. So it becomes 12 radical 5. I'm going to move that radical 5 down here. Does that make sense? Got to remember that. Oh, made a little mistake there. Okay. Now we can add them together. This is just like having x plus 12x. They're a common, no, not common. They're combining like terms is what we are doing. Because they're both being multiplied by the same thing, they can be added together. So there's an understood 1 here, right? So 1 plus 12 is 13. And since they're both being multiplied by radical 5, just radical 5 is left there. So there's your answer. Now, the next lesson is going to be rationalizing denominators. Now, what does that mean? Rationalizing denominators, a couple of big words. Well, let's look at this one. 12 radical 3 over radical 2. Now, a teacher might give you that problem and say simplify, and you'll be like, what? That's already simplified. We can't. There's no rational number that multiplies by itself to get 2 or 3. So what do you want from me? You are expected to know that you cannot leave a radical in the denominator ever. Because we want to know the dimensions. The denominator gives us our dimensions of our fraction, right? And if it's an irrational number like radical 2 is, then we have irrational dimensions, which doesn't really help us mathematically. So we need to rationalize the dimensions of the denominator. That's what rationalizing the denominator means. So how do we do that? Well, we have this trick called multiplying by 1. Anything, any number multiplied by 1 is just that number. Now, but there are different ways we can write the number 1, right? Anything multiplied by anything else over itself is still x, right? Because y divided by y is still 1, because any number divided by itself is always 1. So we can choose which numbers we want. That is something that a lot of people have trouble with, but it's one of the neatest and like most useful tricks in all of math. I love it. So we have to choose a number that will get rid of the radical. Well, if you multiply a radical by itself, you'll get rid of the radical, right? Because radical 2 times radical 2 will give you a 2 in the denominator. Because that would be 2 times 2, which is 4. Radical 4 is 2. What? That was easy. But we have to make sure that the number remains the same. So we multiply the numerator by that same number as well. So radical 3 times radical 2 is radical 6, and we just keep that 12 up there. Now, are we done? Not quite. Well, what am I talking about? Radical 6, there's nothing we can do about that. That's simplified, right? Yes, but this number can still be divided by that number now. And we have an actual, what we call a division problem here. 12 divided by 2 is 6. And there's your final answer. See how easy that was? All we did was multiply by 1. And then double checked ourselves. Wait a minute. Yep, we can divide that. And that is it simplified. All right. Now, multiplying by certain things are also, there are many different ways to rationalize denominators. Sometimes they can get real complicated. So we're going to go over one of those. 2 plus radical 3 is our denominator this time. Whoa. Can't do much about that. I don't know why I wrote an equal sign there. All right. So how do we rationalize that? Well, there's something that we're still going to multiply by 1, but which number do we choose though? Because this 2 constant in front of it is messing us all up. We can't just multiply it by radical 3, because then we'd have this problem. We'd have 2 radical 3 plus 3. Then there's still a radical there, so that won't work. There is a math term. Unfortunately, it's also used in biology, and it means something completely different and maybe pronounced a little differently. But this is called the conjugate. The conjugate of 2 numbers being added together. Pretend there's parentheses around them. And actually write the parentheses, because that really helps. And it's called conjugate. Now, the only difference between these, can you tell? This one's subtraction and this one is addition. That's the only difference. So you just write that same thing with a different sign. See, if this was subtraction, then you would multiply it by 2 plus radical 3. That's the conjugate. Now, we want to multiply it by 1, so we got the same thing up here. And yes, the parentheses matter, because we're going to use the distributive property here, if you remember that. Multiply 7 by both of these numbers. 7 times 2 is 14. 7 times negative radical 3 is 7 radical 3. Now, this part, we're going to use something called FOIL. Hard to spell. FOIL. First numbers, outside numbers, inside numbers, and last numbers. 2 and 2. Those are the first two numbers in both of these parentheses. 2 and radical 3. Those are the outside numbers. So we got the first, outside, inside, last. What did I just say? Basically, we take this number and multiply it by both of those numbers in the other parentheses, and then we take this number and multiply it by both of those numbers in the parentheses. If you just remember that concept, then FOIL makes perfect sense. So 2 times 2 is 4. 2 times negative radical 3, negative 2 radical 3. Radical 3 times 2, positive 2 radical 3. Radical 3 times negative radical 3, negative 3, right? Because radical 3 times radical 3 is radical 9. Radical 9 is just 3 times negative 1. That's why it's negative. But do you see why those two signs are different? So that this happens. This negative 2 radical 3 plus 2 radical 3, any number that is added to the opposite of itself is just 0, right? So we're just left with 4 minus 3. 4 plus 0 minus 3. And we just have a 1 down there in the denominator. And so our answer is 14 minus 7 radical 3. Boom. All right. Felt like I rushed that, but hopefully understand that enough that you can do it yourself with whatever combination of numbers they throw at you. All right. Now, let's try a root of something negative. You remember roots that are negative? Well, that becomes an imaginary number. Not all the time. Remember, this number is now above the check mark, so it's actually the 5th root. So, what happens when this number is an odd number instead of an even number? It means it's not going to be an imaginary number. There is actually a number that multiplies by itself 5 times to get negative 32. Let's factor to find out. 32, it's an even number. So we can divide it by 2, right? 16, right? Yeah. We can divide that by 2 as well. Well, we can divide that by 2 as well. And we can divide that by 2 as well. Whoa, 1, 2, 3, 4, 5. 5 2s. That means 2 multiplies by itself 5 times to get 32. But it's negative. And because of that, all of these are going to be negative. Negative times a negative is a positive. Positive times a negative is a negative. Negative times another negative is a positive times another negative gives you a negative answer. So, because there's an odd number of these 2's, put parentheses around that one, then the answer is going to be negative because there's an odd number. So watch out for that. If you have a negative in the radicand and an odd root, then your answer can be negative. Well, it is definitely going to be negative. But if it's an even and the radicand is negative, then you have an imaginary number on your hands. So yeah, the answer here is -2. And there is only one answer. If it's an even number, then you have the positive negative thing, if that is positive. But yeah. Just because of that rule about negatives being multiplied by negatives being positive.